Thank you, Wendy, and thank you, Becky, for inviting me to come today and speak at this webinar. I am really excited to be here, and I'm excited to see that there's so many people that have joined in on the webinar. I don't think I've ever given a webinar through University of Florida that's had this many people, and so I'm just really excited today. Thank you, all of you that have joined in today. Yeah, the talk that I'm going to be giving today is about reclaimed water, and I was checking the chat box as everybody was chiming in about where you're from and whether or not you have reclaimed water, and I saw some yeses and I saw some nos, and I would say that if you are no right now, chances are that might change in the next 5 to 10 years because there's a push in Florida for us to start using more and more reclaimed water. And so that may change in time if you do not have it available to you right now. So anyway, so yeah, I'm going to just jump right in and start talking about the state of science on Florida's reclaimed water use. And let's see, just to give you an outline of some objectives today, things we'll talk about. We're going to introduce water supply issues in Florida because our water supply issues drive a lot of our reclaimed water use. We're going to talk about how reclaimed water is produced, outline ways that it can be used, including landscape, agricultural and other uses, and then describe some of the chemical constituents in reclaimed water and their fate in the environment. And then we'll talk about best practices for using that water because it does have some things in it still. And so we'll wrap up by talking about best practices, ways that we can use that water wisely to make sure we're taking care of the environment and taking care of our landscapes. Okay, so water supply in Florida, and I put the subtitle here, got an extra 400 million gallons per day because that's when we forecast out in Florida over the next 20 years or so and look at our population growth and the water supply that we feel like we're going to need, and we look at the water supply that we feel like we've already developed, we know that we have, we recognize that we're going to be a couple 100 million gallons per day short. And so that's making us think, where else can we get this water from? And and this little graph, um, what I want to point out here is the different colors in the water bottles indicate different users of water in the state of Florida. So the bottom dark area is agriculture, and these numbers represent a million gallons per day. Well, actually, the numbers in the water bottle indicate percent. So, like on the first water bottle, 39.9% in 2015 was used by agriculture. In 2015, something important happened in Florida. For the first time, agriculture became not the number one user of water in Florida. If you look over in 2020 and 2025, the next little area above in the middle part of the water bottles, the light blue, has a bigger number than the dark blue in the bottom. That light blue represents public supply, which is pretty much just urban irrigation users. So people irrigating their lawns. That became the biggest user of water in Florida in about 2015 and remains today the biggest user of our water. And second to that is agriculture. So urban landscapes, people irrigating their lawns, are a big user of our water supply in Florida. And when we take the state as a whole and we project out over the next decade or so, this map indicates water supply needs around the state. Each pie chart, the blue area indicates future water need that we feel like we can meet by current water supply sources. The orange parts of those pie charts indicate future water needs that we're going to have to develop. We don't yet know where that's going to come from. The good news is there's not a lot of orange on that map, but the bad news is there's orange on this map. It means that there are some parts of the state where we've got future projected growth that we're not quite sure yet where we're going to have the water supply that we need for that growth. And so we definitely need to start taking a look at how we're using our water supply in the state. And so with that projected statewide shortfall of like 337 million gallons per day, we start asking, where can we get new water from? And I've got some options here. One of those is just conservation. Maybe we can find ways to use less water, like low flush toilets and things like that. Conservation definitely can help us get rid of the orange parts on that map I just showed you. But reclaimed water can be a source of new water for us, new water that we can use for applications like agricultural irrigation or urban irrigation or other applications And then there's some other things on there, like at the very end, we talk about using lower quality water like brackish groundwater that's kind of salty, but we know whereas that might be okay for some applications, and a lot of landscapes are not going to really do well with that. So I'm going to focus on reclaimed water today. Okay, first we'll talk about how reclaimed water is produced. It's also called recycled water or reuse water. You can hear any of those terms used, usually intermixed. They all mean the same thing in Florida, reclaimed water or recycled water or reuse water. And the reason for that is that it is former domestic wastewater that has been treated and disinfected at a wastewater treatment plant. So all of the water that we use in our homes, it's sent to a wastewater treatment plant. If you're not on a septic system, not on a septic system, if you're on central sewer, it goes to that wastewater treatment plant where it is treated. And after it is cleaned, treated and cleaned, and in Florida disinfected, it can then be sent back to communities for reuse, which is why we sometimes call it reuse water or recycled water. It's like we're just recycling that water. We're sending it back to use it again. And it's always transmitted in those purple pipes like you see there. So at the wastewater treatment plant, like the one you see here, there's a couple of different processes of treatment. The first is just called primary treatment, and in that process, sewage is held in a big basin so solids can settle to the bottom. So you've got all the solids that settle down, and then you just have the liquid portion. I think we all have a pretty good idea of what the solids and the liquids are. The liquid portion just floats around, not float, is there at top of the solids, and it gets moved on and goes to secondary treatment. Secondary treatment is where that water that was left behind is then chemically or biologically treated to remove impurities. And it's a very good process that does a wonderful job at protecting public health for us and providing a clean treated water. And sometimes we'll even add an extra step at the end, advanced treatment of some kind to further remove harmful chemicals and pathogens. And there are a couple of wastewater treatment plants around Florida that used advanced treatment, but not all of them do. In Florida, to have that water sent back for reuse to communities, it has to have at least secondary treatment. So it's very clean by the time it goes through secondary treatment, but it's gonna have a few things still in it still, and we'll talk about that in a minute. Okay, and by Florida law, reclaimed water that has received at least secondary treatment and basic disinfection and is reused after flowing out of a domestic wastewater treatment facility. That water is what we can call reclaimed water and that we can use in our communities and neighborhoods for irrigation or for agricultural purposes for irrigation. That's written into Florida law that it has to have at least secondary treatment and disinfection to treat any potential pathogens that might be in it. In Florida, reclaimed water use is regulated by Florida Department of Environmental Protection. It's always transmitted in those purple pipes that are kept separate from drinking water, just so that we have different flows for that water. Because if there is anything potentially dangerous or harmful in that reclaimed water, we want to keep it separate from the typical drinking water. And any areas that use that, they have to post the signs to alert the public of that. And we've all kind of seen those purple signs, do not drink or reclaimed water in use. I see those not only all over Florida, not only all over the United States, but all over the world. Wherever I travel, I always look for the purple signs that talk about reclaimed water. And I've seen those in many places of the world. And we always point out that reclaimed water, even though it has been treated and it's very clean, should not be used for drinking or sanitary purposes, so don't take a bath in it, and cannot be directly applied to edible crops that are not peeled, skinned, or cooked before eating. So you can irrigate your vegetable garden with it, but don't irrigate like maybe your lettuce, something that's not going to be skinned or peeled before you eat it. And not for pools, spas, or children's toys. Don't let the kids fill up their water guns with it and squirt each other in the eye with it. Keep that reclaimed water separate from human contact. So ways reclaimed water is used in Florida. Let's talk about that a little bit. So we've got lots of pathways here coming from that wastewater treatment plant. And so pathway number one up there at the top, you can see is going to a factory. Sometimes it can be used for industrial purposes like cooling water in some of the factory processes that need cooling water. That's a great way to use reclaimed water. Those factories don't need super clean water to just be involved in a cooling process and some sort of manufacturing process. So that it can be used for that. Pathway number two here, it looks like it's going to a stream or a wetland. We do sometimes just use that water, that reclaimed water, to replenish wetlands or uh, fill in streams, surface water bodies in the state of Florida. And that's a good way of using that water as well. If we've got wetland areas that are starting to dry out a little bit, why not augment them with some of our reclaimed water? Perfect. So we do that. Number three, you see, of course, is when when the reclaimed water is going to a farm for irrigation. Let's see, where's number four on my map here? I'm not seeing four. It's probably hiding somewhere. Other things that you see, oh, four, the recharge basin. Sometimes we just um, send it to an area and use sprinklers to sprinkle it onto the ground in large areas called recharge basins, and then it just infiltrates into the soil and recharges the groundwater for us. Also a very good use of that water. And in that process, we sort of assume that if there are any pollutants or contaminants still in that water, they get removed as that water infiltrates through the soil. So really good process there. And then some of the other things that you see going to the city maybe for urban irrigation. It can do that. And there's also this pathway here, number six, going to the water treatment plant. We can actually send that water directly back to a water treatment plant where it goes through further treatment, further cleaning, polishing, we sometimes call it, to get it extra super clean. And then it just goes right back to the communities as drinking water. We call that potable reuse. So instead of using our treated wastewater for irrigation or for factories or things like that, we send it to the water treatment plant. It's further treated and then sent out for drinking water. Again, potable reuse, that's called. So some potable reuse basics here. We can have indirect potable reuse or direct potable reuse. Now in Florida, as is most of the United States, most of our reuse for potable purposes is indirect. So it starts at the wastewater treatment plant, it's cleaned, and then it goes to some environmental buffer, like a surface water body or the groundwater, and then it's pumped up from there at the water treatment plant and further cleaned and sent out for reuse. Direct potable reuse is where we remove that environmental buffer. So it's treated at the wastewater treatment plant and goes directly to the water treatment plant, where it goes through the process there and then sent to communities for reuse. We do have a couple of cases in Florida where we're piloting direct potable reuse, but for most purposes, we use only indirect potable reuse, and that's the case in most of the United States. Let's look at a map of the US and talk about who uses reclaimed water. Well, the three states that use it the most are in purple there, California, Texas, and Florida. Kind of makes sense, when you think about population growth and climate. Florida, though, is the national leader at about 884 million gallons per day. That's how much reclaimed water we use in Florida every day. We use more than any other state, and we've been using it for a long time. We've probably been doing it longer than any other state has. Started in Pinellas County in Florida, and then just kind of has started taking over the whole state, and we're now using more than anybody else in the country. And how does it get used in Florida? Well, the big part of that pie chart here, it's the 64% in blue, public access areas. That is residential irrigation for the most part. So about 64% of that 884 million gallons per day of reclaimed water that we use in Florida is used for irrigating lawns and public areas, like green spaces in our communities and parks and golf courses, things like that. And then some other things that we see on there again, like wetland hydration, just augmenting our wetlands, industrial uses, groundwater recharge, and agricultural irrigation, all things that we've talked about. But by and far, and the big message of this pie chart is most of it being used as urban lawns. And so public access irrigation in Florida, about 420 million gallons per day, over 160,000 acres of lawns, and 72,000 something acres of golf courses, also parks and schools. So that's a lot of use of that water every day. And then for our crops and our irrigation, quite a bit less, but we're still using it for that. Over 13,000 acres of edible crops and 23,000 acres of non-edible crops, so like hay for horses and things like that. And again, by Florida law, I'll reiterate this, by Florida law, crops intended for human consumption must be peeled, skinned, cooked, or thermally processed if directly spray irrigated with reclaimed water. And that's just to keep people safe from anything that might still be in that water. Okay, and then in 2021, we had a really important bill passed in Florida, Senate Bill 64 in Florida, and we're still working through the requirements of this bill. But in 2021, it basically said that it requires utilities to develop plans to eliminate non-beneficial discharges by 2023. Okay, by that, I mean that it says that wastewater treatment plants, when they clean that water and they've got reclaimed water and they got to do something with it, that if it's not sent back to communities for reuse, the option that typically is that it's discharged somehow. It's discharged into the ocean or Tampa Bay or the Hillsborough River or whatever river or stream might be nearby. But by Florida law now, since 2021, we can't have that discharge into water bodies anymore. So every wastewater treatment plant that's got this reclaimed water, what are they going to do with it? And that's why I said at the beginning of my talk, if you don't have reclaimed water in your neighborhood now, chances are you might have it pretty soon because all over the state, counties are hustling to meet the requirements of this new law. They're not going to be able by 2020, by 2032, they're not going to be able to just discharge that water anymore. They're going to have to put it to some kind of beneficial reuse, such as sending it out for irrigation or some of the other things we talked about. And that law also establishes reclaimed water as a source water for drinking water, makes potable reuse projects eligible for supply funding. So there's some funding that's being provided by the state to study and pilot test some of those potable reuse projects I was telling you about, where we're just going to take treated wastewater and turn it into drinking water. And we're really putting a lot of focus and study and research into what are the implications of that? Are we sure it's safe? Do we have the infrastructure to do that? Can we get people to buy into that? Think about that yourself. Or do you buy into that? Do you do you want to know that when you turn on your tap and drink that water that it was wastewater just a few months ago? Things to think about. And so just wanted you to know that we're moving in that direction because of our water supply needs in the state of Florida. And then let's talk a little bit about what's in that water and what do we need to be concerned about. So, from a gardening and landscape perspective, I always put this slide first for this audience because as treated wastewater, it can have some salts and other inorganic compounds in it. Salts are very common in wastewater. They're used like in cleaning supplies, like your laundry, detergents, and things like that. And so it becomes part of the wastewater stream, and they're not always completely removed by the wastewater treatment process. So reclaimed water can have elevated salts in it, high levels of sodium chloride and boron, because they're used a lot in those household products. And this picture that I have here is a mango tree, and you see the brown tips of its leaves. That's a poor little mango tree that has been irrigated with reclaimed water, and it's suffering because of the salt damage. It's not tolerant to excess salts, and there is a publication that I recommend. It's listed here on the left side of the screen, Salt Tolerant Plants for Florida. So if you're in a county that's using a lot of reclaimed, or you get to be where you're using a lot of reclaimed, and the people that you're working with are seeing salt damage to their landscapes, take a look at that publication, Salt Tolerant Plants for Florida. It'll help you choose plants that can take a little bit of that excess salt and they won't be damaged like this poor little mango tree. All right, this gets kind of sciencey. Excess salts injure plants through a number of ways, and you look at my slides here. So one of those is just decreased water pressure and what's called physiological drought, because as the salt moves into the soil, it tends to pull water out of the soil, and it makes the plant think it's experiencing drought. It can also do foliar damage to the leaves, like we saw, and it can also just cause ion toxicity problems. As things build up in that soil from the reclaimed water, it can damage the plant that way. And salt buildup is not typically a problem in Florida because of our abundant rain, but for coastal areas, be aware of that risk and look for for indications that maybe landscape plants might be having some damage from the salts, and be sure to look for salt tolerant species. So here's just some guidelines. We've mentioned most of this already. If you suspect salt problems in your soils, get that water. You can get the irrigation water tested. Just turn on the sprinkler and right there, the sprinkler, get some of that water and put it in a little bottle. and get your soil tested, send it to the IFAS extension labs and get tested for TDS, which is a measure of salinity. Also be sure to plant and to recommend plant salt tolerant species. Watch for leaf yellowing and rule out that it's not caused by overwatering, but that can also be a sign of salt damage. Consider drip irrigation for sensitive species and maintain good soil drainage. That's going to help move things through the soil and so that things don't get built up there in the root zone of your plants. So maybe add some organic matter to help break up soils, keep good drainage, keep things draining well. Consider drip irrigation for sensitive species. Plant those salt tolerant plants. Awesome things to be aware of as we use more and more of that reclaimed water in our landscapes. It also has nutrients in it, nitrogen and phosphorus. And I'm sure many of you have heard many talks about nitrogen and phosphorus. If you've been to any of my talks before, you've heard lots and lots about nitrogen and phosphorus because I do a lot of work with nutrients, especially nitrogen. But those are the chemical elements that we are very concerned about in Florida from a water quality perspective. Those two elements, nitrogen and phosphorus, especially nitrogen, are responsible for a lot of our water quality impairments in the state. For our harmful algal blooms that we get, on the west coast of Florida, we get the red tide, and on the east coast, we get some of the blue-green algae sometimes. A lot of those can be proliferated and prolonged, made worse, made to last longer if there's excess nitrogen and phosphorus in our water bodies. And that nitrogen and phosphorus can come from urban landscapes. It can come from a lot of sources, but our urban landscapes can definitely be a source. And so that reclaimed water that we're using, we need to be aware that it's got some nutrients in it as well. And just some numbers here. I was going to show you. Let's see. You can see like typical nitrogen and phosphorus concentrations in untreated wastewater after it has undergone secondary treatment. So you see all those numbers start going down after secondary treatment and how much they go down after advanced treatment. That's why we sometimes have wastewater treatment plants in Florida that do advanced treatment because we realize the need to really get extra new nitrogen and phosphorus removal from that water so that we can use it in our urban landscapes and not be contributing to problems like algal blooms by just adding too much nitrogen. But that unfortunately is not the case throughout the entire state. Those advanced wastewater treatment processes are expensive, and many of our counties don't have that advanced technology. And so, for the most part, we're only getting secondary wastewater treatment. So, when it leaves that secondary wastewater treatment process, it's still got quite a bit of nitrogen and phosphorus left in it. There can also there's the possibility of some pathogens that could still be in reclaimed water because it is former wastewater. These can include bacteria, viruses, protozoa, and even parasitic worms. And I always point out there have been no uh, documented cases of infection from reclaimed water in Florida. But these these pathogens have been detected in reclaimed water in various places throughout the state, just no documented cases of infection. So I don't think that it's worth being overly concerned or worried about it, but I do think it's worth being cautious. And so I always tell people, wash your hands and wash your veggies. After you come in contact with reclaimed water in any way, just go in the house and wash your hands real good. And if you're irrigating your vegetable garden with it, wash your veggies really good before you eat them. And again, don't like maybe irrigate your lettuce, things that don't get cooked or boiled in some way, just because there can be still some viable pathogens maybe in that water. And maybe you've heard of the emerging contaminants and things like the household chemicals that we're recognizing more and more are contaminants in our environment. The things that are just ubiquitous, they're everywhere. You see some examples here, medications and household chemicals. All of those things have chemicals in them that can get into the wastewater stream and then become part of the reclaimed water. And if we're irrigating our food with them, they might be taken up by that food crop. Maybe your carrots have a little ibuprofen in them or things like that. So research is ongoing on that. We have a number of researchers at University of Florida who are working on that and trying to identify those pathways and how much of a problem is this. Just some pathways here that you might see, like for example, compounds from that wastewater treatment plant being uh, accumulated in the soil, then they can be taken up by that plant, and you can see if that was an edible plant that we humans then ate, then we would be taking up those chemicals into our bodies and um, I want to point out that's an extremely small dosages. I mean, you would have to eat like 20 pounds of broccoli every day of your life to get the equivalent of one ibuprofen tablet, but they're very small amounts, but they are there. And so research is ongoing as to what that means for us. So just some conclusions for that, and then I'm going to give you a case study from Eastern Florida, but some conclusions thus far. Reclaimed water is highly treated wastewater returned to a community for beneficial reuse, and that could be lawn irrigation, agricultural irrigation, wetland recharge industry, or even potable reuse. Florida is a national leader in reclaimed water usage, and it's often seen as necessary to offset the use of potable water because our groundwater supply is limited, and especially as our population continues to grow. There are efforts to increase the beneficial use of reclaimed water, and we're working on that. We're working on getting the funding and the regulatory frameworks and everything that we need so that we can continue to use more and more of that. And we do need to recognize, though, that it can contain salts, nutrients, pathogens, and emerging contaminants. So we want to be aware of this and account for that in our landscape plans. And I always get asked if we can account for the nutrients in a fertilizer plan, and the answer is yes. And I know some of you are probably in counties that encourage that and publish how much nitrogen or phosphorus is in the reclaimed water, and that way you can say, oh, well, my reclaimed water is adding 3 pounds of nitrogen to my yard every year, so I can reduce my fertilizer schedule by X amount. Some counties are better about that than others, but definitely if you ever have questions about that or want information on that, shoot me an email and I'll just see if I can help you with that. Okay, so to wrap it up, I wanted to um, give you a case study of some work that a student in my lab did. This was done by Dylan Barr, who was a master's student in my lab a few years ago. And this work was done in the Indian River Lagoon watershed over in the eastern part of Florida. We were primarily in St. Lucie and Martin counties over there. So let me just introduce you to this project. So he wanted to know what were the environmental consequences of what we call irrigation overspray. And I promise you, all of you have seen overspray, even if you are not personally responsible for it. I know you've seen it because you live in Florida. That's when, the sprinklers are running, and instead of just irrigating the grass and the vegetated area in the lawn, it's also irrigating the streets and the sidewalks, and it's running down the streets and it's running down the sidewalks, and like the pictures you see here, like the wedding pattern that's on the asphalt. So that's what he was interested in. And um, so Dylan got a drone, and, or more specifically, I bought him a drone, and he used that drone to fly over in a couple of neighborhoods where he was studying and capture images of that irrigation overspray, like the images you see here. And then we were able to put that into some special software that takes those images and turns that wetted area into a surface area, an area on the ground. So, for example, 200 square feet or something like that. So he was doing that. So he was in a neighborhood, and every time the sprinklers would run, he would fly his drone over and take pictures like this, and then put it into his little software and get the area. And then he also was out there. He put out catch cans in that area, and you may have seen these before, where you put these out there and run the sprinklers, and the water accumulates in those cans, and they're graduated, so they have numbers on them, so it'll give a value like 6 milliliters or 10 milliliters, whatever the case may be. And so with that, he was able to say, over a certain area of land, we had so many inches of water that was applied by this wasteful irrigation practice of overspray, and he was able to convert that into an amount of water. And then at the same time, he collected that water and he analyzed it for nitrogen and phosphorus content. And once we have the depth of that water that we know has been applied to the streets and sidewalks, we can multiply that times the concentration of nitrogen and phosphorus in it. And that will give us something called the nutrient load, which is just pounds of nitrogen, pounds of phosphorus. So we combined all those data pieces together to tell the final story. And the first part of that story was just simply we asked the question, how much are people overspraying? How much does this occur? And the average is the number that you see there on the top right side of this slide, about 33.7%. So in other words, every time people are in this neighborhood that we were in St. Lucie County, every time they were irrigating, on average, 33.7%, almost 40% of the water that came out of those sprinklers was landing on hard surfaces like streets and sidewalks and asphalt. So average overspray, almost 40%. That's a lot of water being just wastefully applied to hard surfaces. And then he started putting in the numbers of the nitrogen content of that water and some of the data that's here. So the neighborhoods are on the far left here. Jensen Beach Country Club, Harbor Ridge, Willoughby Cay used groundwater. It was our non-reclaimed water reference to compare things to. But you can see just the concentrations here, how much they varied. I always hone in on that column that says mean total N, that's total nitrogen. I always hone in on that one. Jensen Beach Country Club, their total nitrogen in their reclaimed water was 5.6 milligrams per liter, but in Harbor Ridge it was only 0.8. So why that difference? They're almost in the same county. Again, it's just differences in wastewater treatment plants. They all are different. They all have different technologies. And so that's why that water was different. That's important to know is that wherever you are in the state, your concentrations of nutrients might be different. So in this case, those two neighborhoods had really different total nitrogen values because of the treatment processes at the wastewater treatment facility where that water came from. And then he did his calculation to produce the load or pounds of nitrogen per year being dumped into the environment. And the HR stands for Harbor Ridge, and JBCC is the Jensen Beach Country Club. Remember, that was the one that was higher. And so if in this table, it's just the assumption, if everybody was irrigating with water typical of that found at Harbor Ridge, these are the values we might see. Or if everybody was irrigating at values typical of Jensen Beach Country Club, these are the values we might find. So again, hone in here on the row that says TDN, that's total dissolved nitrogen. TDN, 0.27 to 3.12 pounds. So if you were using water typical of that, like Jensen Beach has, reclaimed water like Jensen Beach has, and you're irrigating, you're going to be applying about 3 pounds of nitrogen, which is a pretty good number. It's probably half or more of the nitrogen that most of those lawns need. And so he made these points after doing his study. Even without nutrient loading, overspray is an issue. So even if that water had no nutrients in it, we're still just wasting if we overspray. So he would always point out that that's wasteful use of a valuable resource, especially here in Florida. And we need best management practices to reduce overspray and waste so that we're not wasting that water. We're not sending those nutrients down the street because that's how we get harmful algal blooms. So I want to wrap up today by sharing some best management practices for irrigating with reclaimed water, tips for homeowners and landscape personnel and master gardener volunteers like all of you here today. So first of all, know the composition of your reclaimed water. You can call or search for your water provider on the internet and learn about the level of treatment your reclaimed water has undergone. Was it secondary? Was it advanced treatment? And ask them to provide or share with you any data they have on the typical chemical makeup of the reclaimed water you use. It may have just a little bit of nitrogen and phosphorus, or it may have a lot. And while the chemical composition of reclaimed water, including its nutrient concentration, may vary by season, the provider should be able to give you a range of high and low expected values and any other potential pollutants like salts. And so if you know what's in it, then you can start making plans for how best to use it. And usually I find you have to call them and ask for it. I would love it if that information was something I could easily find on the internet, but I have never found that to be the case. I usually just have to call the utility and say, hey, will you please share this information with me? And I promise I'm not going to put it in the newspaper and publicly share it to the world. I just want it for my own purposes so I can plan. Usually they'll agree at that point. Second best management practice is use the Florida-friendly landscaping principles, which include right plant for the right place. And so in this case, you want to consider plants that can handle potential elevated salts in reclaimed water. So if you know you're going to be using that water, consider the right plant for the right place and plant those salt-tolerant species again. Also, keep irrigation equipment working properly. A good rule of thumb is to check your irrigation system 2 to 4 times a year to make sure there are no broken lines or sprinkler heads. And once every few months, audit the performance of your irrigation system to check for correct application volume and uniformity. And those checks are also going to During those checks, also, make sure you're not irrigating the sidewalks and the streets, those kinds of things. Turn those sprinkler heads so that they only irrigate vegetated surfaces. And that's not only gonna save water, but it's gonna reduce the chance that excess nitrogen and phosphorus get applied to the streets and sidewalks and start running down the streets to the canal that goes out to the Indian River Lagoon or Tampa Bay or whatever the case may be. Avoid irrigation overspray. Inspect sprinkler placement, pressure, and device type to ensure optimal operation. Often the wrong spray head is in the wrong place, which can lead to overspray and excessive runoff. Irrigation overspray occurs when irrigation water lands on sidewalks, streets, and other non-target areas. And this wasteful use of water not only diminishes water supply, but can also be a means of nitrogen and phosphorus transport to local surface water bodies. So teach the people you work with in every way that you can to avoid situations like the picture here. I mean, it looks like we're in the middle of a hurricane, and it's just the irrigation water landing on the sidewalk. It's not a good situation. And finally, even though it's reclaimed water and it's cheaper, maybe even free, depending on where you are, don't overwater. And as master gardener volunteers, you guys know this. Overwatering is overwatering is overwatering, and it's damaging to your lawn. So only irrigate when soil and turf conditions indicate that irrigation is necessary. And a good rule of thumb is only 3/4 to 1 inch of water is needed each week for most Florida turf grasses. And I think that number is going down. And last I saw IFAS recommendations, I need to check on this, but I think they're starting to say closer to a half to 3/4 of an inch a week for some of our turf grasses now in certain parts of the state. So check with your local, county extension offices and see what the recommendation is for your county. All right, conclusions. Reclaimed water used to irrigate thousands of acres of lands for homes and other urban areas in Florida, and it's a great way to offset potable water use, providing resiliency against our water supply scarcity that we're predicting for the future. But reclaimed water can contain elevated nutrients that can impair surface waters. University of Florida research in the Indian River Lagoon showed that as much as 34% of applied lawn irrigation was wasted as overspray, which can have both nitrogen and phosphorus. And best management practices for homeowners and landscape personnel can ensure that reclaimed water is used in ways that protects water quality. All right, thank you for your time today, and I'm going to take questions at this point. Thank you.
Hi, Mary. Thank you so much for your presentation. We've got a lot of great questions in the Q&A, so I'm going to hand them over. There's a couple of terms that people have been asking for a little bit of clarification on. First off, what is groundwater recharge?
Okay, yeah, really good question. Yeah, thank you for asking questions like that. So, okay, so we've got groundwater, right? The water that's in our aquifers below the ground, and that we use a lot of that in Florida for our drinking water. In fact, Florida is one of the top states in the country for using groundwater as a drinking water resource. So we're pumping that water up out of the ground and we're using it for mostly for our drinking water. Recharge is when an action like rain returns water to that resource. It's rain falls on the ground and infiltrates down through the soil and it returns to that aquifer and becomes groundwater again. So recharge is just the process of rain percolating down through the soil and becoming groundwater again for us.
Perfect. And then there was a question about what is TDS?
Okay, total dissolved salts. So yeah, so that's why you want to ask for that when you send your water sample to be analyzed, because that's going to tell you, what's dissolved in my water. Is there dissolved sodium, chloride, all of those salt ions that might be in there? Yeah, good question.
Perfect. And if you were doing a soil, like a standard UF extension soil test, is that something you can ask for, or is that something you can look for in the results, or is that something you can even request?
It is, yeah. So on that form that you will send when you send a sample to the extension lab for analysis, there's going to be all these tests that you can choose from. Which ones do you want? And there should be something that says salts or TDS or something like that. And if you need help with that, talk to your county extension agents. That there should be somebody in every county that knows all the ins and outs of those forms and how to how to read them and interpret them and yeah. Yeah.
Of course. Extension office is always a great place to start. We're also getting some questions about sort of predicting the future of using reclaimed water. And we're getting some questions about will reclaimed water be metered in the future? Is that something you've been hearing about? Is that a possibility?
So that's certainly been discussed. I have no idea if it's going to come to be or not, but I will tell you that it has certainly been discussed. It is a discussion that county and state environmental personnel are certainly looking at. And, it probably makes a lot of sense to meter that in some ways. But, in a lot of ways too, sometimes, the wastewater utilities push back against that because it's a it's a product that they produce and they have to get rid of it somehow. They're happy to just send it out and let people use however much they want to use. And so there's a little bit of pushback, but I will say that that conversation is happening. Yeah.
Perfect. How can reclaimed water be used as part of a multi-pronged approach to help protect and conserve water resources in Florida?
Oh, I love that question. I'm going to turn that into a scientific paper. That's a great question. That's going to be the title. Whoever wrote that question, send me an email. Let's write a paper. Um, Yeah, I always say that we have got to use that water in Florida because we need to offset our potable water use. When I showed that map of the little blue and the orange circles across the state, and we see that most of the state, it was mostly blue areas. We know with population growth we can meet our water needs, but there are some parts of the state, especially in Central Florida, in that Orlando, Kissimmee area, where we're like, we don't know. So we've got to use reclaimed water to just supply the water that we need. But just like I pointed out at the end, sometimes we're very wasteful with that, and sometimes that water has nitrogen and phosphorus in it, which can lead to our harmful algal blooms or make our algal blooms worse if they're already out there. So how can it be part of, an integrated sort of holistic approach to Florida? And my answer that I always say to that is we've got to use it, but we've got to use it smartly. We've got to have some regulations, maybe, and if not regulations, at least some best management practices that we make sure people know about and make sure people are using those best management practices. And I love that this is the Master Gardener volunteer audience because you guys are like the little army that's going to be out there sharing those best management practices and helping get that message out.
We've got a question about the color of the pipes. I know you covered this at the beginning, but I think it's great to say again, just to clarify for anybody who maybe logged on a little bit late or doesn't really understand the color of the different pipes and what they indicate.
Yeah, so I mean, there are different pipes, for different uses. I'm going to confess that if it's not purple, I don't pay much attention to it. So I know there are different colors. I would imagine blue means potable.
Yeah.
And purple is just always, and it's like that wherever I go in the world. I've been to Australia and found purple pipes. And so it's just somewhere along the way, somebody decided reclaimed water is always transmitted in purple pipes. And that's the case.
That's nice. I think it's adding some color to our landscapes,
Yeah.
Um, I'm trying to let me see if there's some more in here. There's really lots of good questions. There's a lot of questions about HOAs and using reclaimed water. How can we talk to our HOAs about using that responsibly? Is there a way that we can begin and kind of open up that conversation about how to use it responsibly?
Yeah, another really good question. Boy, that makes me think of another paper that I probably need to write. Um, yeah, those best management practices that I talked about at the end of this talk. We need to get people aware of those, and we really especially need to get HOAs on board to help us support our efforts to avoid that overspray situation. And I'm sure you've all seen that. I mean, I see it all the time. I say we irrigate our lawns 12 months of the year, rain or shine in Florida. I'm sure you've all seen it. It's raining and the sprinklers are running, or the water is flowing down the street. And if we can get our HOAs on board to encourage people to take care of those sprinkler systems so that we avoid that situation. That would be wonderful. And maybe a good way of opening up that conversation is to talk about the connections between nutrients and things like the harmful algal blooms that we deal with so much in Florida. If we can get people to see, look, there's a connection. What you do in your lawn is connected to what happens downstream in Florida. Maybe that's a good way to open up that conversation.
Thank you for that, Mary. Got another question here about microplastics. I know you mentioned pharmaceuticals, that those can kind of turn up. What about microplastics? Are those getting kind of cleaned out in the earlier stages when it's kind of going through that cleaning phase, or is that something where we might get washed down with us?
So unfortunately, we are seeing microplastics in that water. Yeah, I have a colleague at University of South Florida in Tampa who does some work on microplastics in stormwater ponds in the Tampa Bay area, and they're seeing all kinds of microplastics in stormwater ponds. Well, how are microplastics getting in the stormwater? Most likely from reclaimed water used as irrigation in the neighborhoods. And so it's in there. Yeah, another field that is wide open for investigation and research right now. Yep.
Well, great. I think we've given you a lot of good topics to continue and pass it along to your students to get them on help getting helped with. A lot of comments about how wonderful this presentation is, Dr. Lusk, and we really loved having you here. I'm kind of see if there's any more we can do. I mean, there's a bunch, so we could go on for time and time. Um, the question is about lots of questions about using reclaimed water on crops. And I know you mentioned that they can be used for agriculture. Can you specify again, just for clarification, what it's used on and what it is not recommended to ever be used on?
Yeah, so we use a lot of it in Florida for citrus, and when we do, we use drip irrigation for that. So it's just drip irrigation. It's irrigating right there at the trunk of the tree at the soil line, so that water is not landing on those citrus fruits in any way. So if it's being done correctly, those fruits are not coming in contact with that water, which is good. Um, we by law cannot use it on, again, anything that's not boiled, skinned, or cooked in some way before consuming. So what might that be? Maybe like blueberries or strawberries, something that people are just going to go out and pick and maybe just eat right away. Nope. I have a PhD student actually who's studying reclaimed water used for blueberries, and I would love to. She's looking at like what happens in the soil, which is good, and it's good research. But I would love to take some of those blueberries and squish them up and send them off to a lab and see what's in those blueberries. Um, yeah. So, but again, yeah, we can't use it for anything that people might just pick and eat. It has to be something that's going to be cooked, thermally processed, skinned somehow.
Perfect. Thank you for that clarification. I think that's put a lot of people's mind at ease.
Yeah.
Also, getting a lot of questions about irrigation or misconception, maybe about retention ponds and water coming out of retention ponds, if that's reclaimed water or if that is something completely different and not really part of this conversation.
So the answer is it could be. I do know of neighborhoods in Florida where that is the case, where there's maybe like a small community wastewater treatment plant, and water goes first to a pond, and it's held there, and then that is then sent out for irrigating with. So it could be. I know of other cases where the retention ponds, no, they're not getting any reclaimed water influence. It just for some reason I don't know what makes the difference, why some places do it differently than others. I probably should know that, but I don't. So the answer is it could be, but it could not be.
It's sort of a case by case basis.
It is, yeah.
Okay. Someone else was asking when a neighborhood is getting reclaimed water, like installed or having the option, who's covering the cost of installing that? Where is that funding coming from?
Good question. So with that new law that I told you about that came out in 2021, there was some funding set aside for expansion into a lot of areas. And so hopefully, in most cases, that funding should be coming from the water management districts, which then funnels into the counties, the municipalities that are going to be managing that. As far as I know, homeowners are not asked to help foot the bill for that, but as we all know, eventually everything comes down to money, so that could change. But right now, there should be funding that's being funneled from the water management districts to support those projects.
Fantastic. Got a question about reclaimed water that's being used to help restore those wetland areas. Are there any concerns about sort of the same things that we're talking about when we're talking about irrigation, about sort of that nitrogen and phosphorus maybe going into those wetland areas?
Yeah, so wetlands are wonderful for treating excess nitrogen and phosphorus. Wetlands are so good at that. Wetland plants take up a lot of that material. Wetland soils do a lot to remove those which is why sometimes we have wetlands at wastewater treatment plants for that very purpose, to polish the water, they call it. Wetlands are just nature's natural little cleansers. And so um, for nutrients, no, there's no concern because wetlands do such a wonderful job of removing those contaminants already for us. Now, there is a little bit of concern about what about some of those emerging contaminants? We do think about that a little bit, and there are some researchers that do work on that and look at that. And I have seen some reports that indicate that some of those compounds end up still in the wetland, and then it becomes a concern for aquatic wildlife. It can be taken up by different species that depend on those wetlands. So darn it, there is a little bit of concern there. They're wonderful for removing nutrients, but some of those more persistent compounds are just hard to get rid of.
Yeah, there's no easy wins, huh?
Yeah.
Okay, well, I'm looking at to see if there's any just so many great comments about how wonderful the presentation was, how needed this information was. Um, and everything else. So I think we're going to wrap it up here, Mary. Thank you so much for your time. And I'm sure if anybody has additional questions there, they can reach out to you or reach out to us. And we will see you guys back here for the next MGV webinar, which is going to be February 26th. So thanks so much, and we'll say goodbye for now.
All right. Thanks, everyone. Bye bye.
Bye bye.